Norway has been building hydroelectric power plants since the 1890s. Now, 99.5% of all electrical energy in this country is based on water power. This makes Norway a world authority on the planning and building of hydro plants. More than 200 such facilities have been built into rock, or more than half the world's total for this type of plant. In central Norway, a major power station with tunnel systems is now under construction. The Meråker power station is being built by the Norwegian company Meråker, using state-of-the-art tunneling equipment. Meråker is the site of the North Trøndelag Power Board's biggest hydropower project to date. There will be two power stations. The main station is the Meråker plant with an output of 87 megawatts and a 266-meter head. A pumping plant is also being built for maximum resource utilization. In all, the tunnel system is 43 kilometers long. The plant will replace 4 existing power stations and put out 194% more power. Construction started on September 5, 1990. The North Trøndelag Power Board erected a modern administration building. Meråker is a joint venture between Veidekke and Ek Henriksen, Norway's largest and third largest construction firms respectively. In fall 1990, the world's most powerful mole, named the TBM, or tunnel boring machine, was exhibited at the Robbins Company in the US. The monster arrived at Meråker by train in August 1991 and started tunneling 3.5 weeks later. Before starting up the TBM, we made a comprehensive geological survey in collaboration with the Norwegian energy corporation Statkraft and the Division of Building and Construction Engineering at the Norwegian Institute of Technology. Working with the Institute, we made a detailed outline of the rock distribution based on the survey maps. This formed the basis for cost-earnings analyses. A thorough review of the project from start to finish is crucial to its success.
Her har du tilløpstunnelen til Meråker kraftverk.
Project engineers consider all economic factors in order to find the best solution. Financial rundowns are generated on a continual basis. On a project of this magnitude, computers are essential for continual budget versus reality comparisons. At Meråker, a TBM is used to drive a 10-kilometer tunnel. This machine guarantees excellent progress. The TBM excavates a full-profile tunnel, 3.5 meters in diameter, each cutter boring with 32 tons of pressure. The TBM is a factory on rails, 260 meters long. The machine is operated from a control room where all functions are monitored. Modern PLC controls simplify operations and make troubleshooting easier. The TBM leaves behind a smooth surface for optimum water flow. The crushed rock is loaded onto railway cars behind the machine and transported out of the tunnel. The operation is supervised from the control room with the aid of TV monitors. At the same time, the operator guides the mole with lasers. The TBM is operated by 5 men per shift, plus 1 cutter repairman. In other words, 16 persons working 33.6 hours per week. This gives 101 hours of production time each week. The tracks are laid as the mole advances. When loaded, the railway cars are replaced with a new set. This ensures continuous operation. The loaded cars are hauled out to the assembly hall by the tunnel opening. Here, the muck is dumped into silos. The muck is then transported by truck and dumped over the edge. This is a fine-grade byproduct and makes a good subsurface for road building after leveling. The weekly progress depends entirely on the nature of the rock. In week 14, 1992, Meråker set a new Norwegian record with 426 meters in a 101-hour week. This machine has brought us high net earnings. Of all such projects in Norway, this one represents the greatest feed power per cutter. The cutters on the Meråker TBM are specially spaced for hard rock drilling. This has greatly improved efficiency. Meråker has carried out more than 40 modifications on the prototype used by the Norwegian energy corporation Statkraft on the tunnel beneath the Svartisen glacier. Every work shift, the cutters are inspected and tightened, and worn parts are replaced. This is important in order to prevent breakdown and loss of valuable production time. The cutters are overhauled by a service expert who keeps a constant eye on discs, bearings, and oil. Repairs are made on site. The contract with the Robbins Company provides for permanent service personnel and a complete store of spare parts. The mold can be dismantled and transported anywhere by rail or by truck. The power station and facilities are being built into the mountain by the town of Meråker. Here, all tunnels are driven by conventional blasting, using triple-boom hydraulic drilling jumbos. Before the crew starts drilling, the blast pattern is carefully drawn onto the tunnel head. Two laser beams ensure an exact profile. To the power company, this means maximum flow efficiency. Economically, this precision blasting technique benefits both the power company and Meråker. The tunnel's cross-section is 32 square meters. Approximately 70 pilot holes are drilled per blast. Each blast advances the tunnel 16 feet. Drilling and loading takes approximately 2 hours. We use side dumpers because of the confined space. The muck is transported out of the tunnel on tandem dump trucks. Direction and profile are checked to ensure quality before and after blasting, and for documentation of the completed tunnel. A 270-meter pressure relief shaft with a 45-degree incline is excavated from the intake tunnel. The work is carried out with 4 men per shift. The shaft has a cross-section of 18 square meters. Here, Meråker uses Alimak equipment. The men drill vertically with handheld equipment. Shaft boring is a demanding operation.